Welcome back to Autistic Coder. Today we're solving the house robber problem using dynamic programming. This is a classic interview question that might seem tricky at first, but once you see the logic behind it, you'll realize how efficient DP can be. Let's break it down. Let me explain the problem. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that if you break into two adjacent houses, the police will be called. Instead of solving this problem starting at the first house, we'll start at the last house. This might seem counterintuitive, but since we're trying to maximize the amount stolen, we start from the last house and work backward to calculate the best possible amount for each house. We'll define n as the total number of houses on the street. We'll create a DP table with length n plus 1, and we'll define DP of I as the maximum amount of money you can get by starting at house I. Let's define our cases. Our base cases are that dp of n plus 1 is 0 and dp of n is also 0. At any house I, there are two possible actions. We can either rob house I and then go to I plus 2, or go to house I plus 1. Since we want to pick the action that maximizes the amount we steal, we'll define the recursive case as dp of I equals the maximum of two numbers, nums of I and plus dp I plus 2 and dp of I plus 1. Here's how I implemented the solution in JavaScript. I initialize the DP array, setting each value of the array to 0. Then I use a for loop to update the DP values. Finally, I return DP of 0. Let me explain further why we start from the end instead of the beginning. The reason is that each decision depends on future outcomes. By solving the problem backward, we ensure that we've already calculated the best possible choices for every future house before making the decision for the current one. Thanks for watching. The house robber problem is a great example of how dynamic programming helps maximize efficiency in real-world scenarios. If you found this video helpful, please like, comment, and subscribe to support the channel. Doing this helps boost my standing with the YouTube algorithm. Donations via the payment methods on screen are also welcome. Thank you, and let's keep learning and growing together.